Hi guys, welcome to the channel 7-inch TS. This is the second video of this series. The first video was my introduction and agenda. In this course I will teach the Civil 3D from 2016 version to the advanced version. So in this video I will give the overview and definition of the Civil 3D. Introduction. The AutoCAD Civil 3D interface enhances the standard AutoCAD environment with the additional tools for creating and managing the civil design information. Standard AutoCAD features such as command line and ribbon work the same way in AutoCAD Civil 3D as they do in the AutoCAD. The AutoCAD Civil 3D is a vertical solution of the AutoCAD. So the feature of the AutoCAD and Civil 3D are the same, but there are additional design tools and standards are added in the Civil 3D. Civil 3D is a building information modeling BIM solution for civil engineering design and documentation. Civil 3D is a software for civil engineers, drafter designers working on the transportation, land development and water projects. Okay. So we can create the building information model in the Civil 3D also. So like road, pipeline and land development projects. So we can model it in the Civil 3D. There are more software additional we are using in the BIM, but Civil 3D is the main software. So next, AutoCAD Civil 3D is the most powerful civil engineering and survey software. Civil 3D has the ability to quickly calculate the quantities of material to be estimated such as concrete, bricks, cement, etc. With the help of Civil 3D, project visualization, analysis and designing become quite easy. So in the Civil 3D, we can calculate the survey calculation very easily and very quickly. It is giving us the data very quickly, and also it is very useful to calculate the quantities very fast. So these are the introduction and the Civil 3D definition. So now next I am giving the overview of the Civil 3D. So next, okay, now I am starting the overview of the Civil 3D. So I will not elaborate the subject, but I will do a brief only. This overview will help you as a beginner to understand how the Civil 3D is working and what are the main function and procedure in order to design in the Civil 3D. So these are the main points of the Civil 3D. First of all, the main topic will be the points. Then after the points, the next will be the surface, then alignment, then parcel, then profile, assembly, corridor surface, simple lines, section views, and pipe network. Now, user interface. The user interface is almost same like AutoCAD, okay, but there is additional tools added. Okay, we have application menu, ribbon bar, command line, tool space, and here is our drawing area. We will create the drawing here. So this one is the transparent command toolbar, inquiry tool, and panorama, the layout and the model. So this is the user interface. So as I told, I will elaborate all these subjects in the future videos. Okay, it is just a overview. In the starting of the project, we are opening a new file and then we are doing some initial setting like unit setting and dimension settings. Then we are going to the next step. Then we are importing the 3D survey points provided by surveyors. These points represent the existing shape of the surface and locations of the existing roads, trees, building, etc. We can look the points in the Civil 3D like this. Points are AutoCAD Civil 3D object that can be displayed in the drawing and manipulated graphically. Point appearance is controlled using point label and point style. So in the Civil 3D we can manipulate it and we can change the point style through point style, and we can add the different type of labels with the points like levels and coordinates, etc. The next, after importing the points, okay, we are creating the surface above the points. Surface are the most basic and necessary element of any project. Surface is a must before creating any road, pipeline, network, etc. The surface is must required for any project. Okay, once we receive the data, then we have to import as a points in the Civil 3D, and then create surface on it using Civil 3D tool. We can import direct the surface also in the Civil 3D from other sources like Google Earth and other mapping softwares in order to use just as a reference. The alignment are basically the series of coordinates, line and curves used to represent the center line of the road, sidewalk, etc. Alignment can also be used to represent the center line of a canal or stream. So after the surface, we are creating alignment. Alignment is using for any road and sidewalk, etc. It is represent the center line mostly. The next is parcel. The parcel is a digital representation of a world lot. Within Civil 3D, parcel can be represented by any closed boundary. Any Civil 3D project often involves the division of large piece of land into smaller properties. You are often required to show the boundaries of your site and adjoining sites. So these divisions are called parcel. So in the Civil 3D we are using Parcel to design the grids and plotting. So there are multiple tools are available in the Parcel. In order to design the grids and plotting, we can give the multiple shape to the grids in the Parcel, and we can calculate the areas, and we can do the numbering and labeling of the plotting. I will elaborate this subject also. Next, after the alignment, we are creating the profile. So we can say a profile is used to represent train data along the horizontal alignment. Data points are generated wherever the alignment intersects a surface line. The profile view is the Civil 3D grid object that shows the profile data. After you create an alignment, the next step in the road design process is to generate the surface profile. So after the alignment we are creating the profile. So we can see in the profile view the existing surface. We can see the datum, the changes, the labels of the existing surface. So then we can create the design profile here also, and that design profile is very important because later on once we are going to create the corridor, so we will follow the design profile, not the existing surface profile. We can design the multiple profiles also in the profile view. Okay, so after the profile we have to create the typical section. So we can say the assembly basically represent the typical section and is the starting point for corridor design. To create the assembly, you added sub-assembly like lines, curves, shoulders and other cross-section elements. Basically, the assembly represents the typical section of your project. Okay. Every road project having different type of typical section. So that's why we are creating the assembly in the Civil 3D from different sub-assemblies. Okay. These sub-assemblies can be lines, curves, shoulders, retaining walls, etc. Okay. We can change the dimension of that sub-assemblies as per our project typical section, and this assembly we will use for to create the design corridor. Sometimes we are not finding the sub-assembly same as our project typical section. So for this purpose we have sub-assembly composer. We are designing the sub-assembly in the sub-assembly composer, and then that sub-assembly we are using in the Civil 3D for assemblies. Okay. So the next step is corridor. For the corridor we have required the surface, alignment, profile and sub-assembly. So then we can create the corridor. So on the base of that we are creating the corridor. A corridor model is a three-dimensional representation of the design for a roadway or any transportation design. For creating any corridor you must have an alignment, a layout profile and an assembly. So after the corridor we can design the intersections of the road also in the Civil 3D. Okay. Sometime in the road designing the two roads are crossing to each other, but in actual the levels is not matching with each other. So that's why we are designing the intersection separately. So in the Civil 3D having very powerful tools in order to design this intersection. With the help of their tools all the corridor levels we are matching with each other very perfectly. Okay, and the intersection tools make it very easy to match these levels with each other. Okay, intersection here can be described as the area on the road where two roads are crossing each other. when we are creating corridor on the alignment which are crossing each other, but in actual they two do not intersect. Okay, so we can say the corridor surface. We can create the surface from corridor. Actually the corridor surface is our output, and this surface is directly linked to corridor. If make a change in the corridor surface will also change. After the corridor, so we are creating the surface above the corridor, so it is called design surface also. Okay, we can create the surface for the formation, and we can create the surface for the proposed ground level. Okay, next, simple lines are required to calculate section views. Simple lines are created on alignments at a different stations. Okay, so in the simple line we can give the different interval in between. So we have to paste the line where we need the cross section. Okay, and the length of the simple line will represent the section width. Okay, for example, simple line length is 40 meter, so our cross section view width will be 40 meter. So if we need more width of the cross section view, we have to increase the length of the simple line, so our cross section view width will be increased also. So after the simple line we are creating the section view. Okay, the section view will look like this. We can change the view also, and we can see the cross section of the road where we paste our simple line. Okay, and we can see more detail inside the section view. We can see our design typical section also, and we can see the existing ground surface also. We can see the levels of the existing surface and the design surface, and we can add more labels for more details in the section view. And this section we are using for the quantities also. Section views are the objects which we can show in the grid that shows all information of sections. It is associated with the geometry or location of simple lines. If we change in location of simple lines, our geometry section view are changed automatically. So in the Civil 3D we can create the pipe network also, and we are creating the pipe network from the pipe and structure parts. Okay, and we can edit that parts as per our project design. We can do the clash analysis of the pipe network, and we can calculate the levels of the pipe network in the Civil 3D. So I will explain the pipe network in the advanced level Civil 3D, and I will try my best to share my experience. A pipe network is created from pipe and structure parts. Part list contain list of pipe and structure to be created in pipe network. Some rules should be kept in mind when you create a pipe network for calculating slope and invert levels. Pipe network can be edited either graphically or in table. You can also use grips to edit pipe network. So that's it guys, the overview video is finished. In the next video I will go in more detail of all these subjects. Okay, hopefully this video will be helpful for you. See you in the next video. Thanks for watching. Bye.